First of all, I want to thank Sweetbridge, our sponsors, and Token News for helping us with the venue. And this is the third in the trilogy. We started on Friday with Hyperledger, and we learned some really big secrets. So all of you who didn't come, you really missed a massive event. Sunday we were at Naked Hub, and this is probably the best of the lot. So I want to introduce Scott, formerly of PayPal, Charles Schwab, Chief Information Security Officer from Sweetbridge. He's going to tell us lots of secrets. Right? Yeah! I'm going to turn the lights off.
So,
I don't know how, but I'm going to turn the lights off.
I would rather not use the mic. Is it okay with everybody that I don't use the mic? Alright. Okay.
Can I make a recommendation? You have to use the words fake internet money. You promised me, right?
I will use the words fake internet money. This talk is not about fake internet money. How about that? So if anybody here is expecting a talk about crypto, this is not what this talk is about.
Everyone's going to leave it.
Yeah, it's not.
Well,
so feel free to leave now. So by way of introduction, my name is Scott Carlson, as you know. I am the security officer for a company called Sweetbridge. But what I am, or who I am, is I've spent 20 years roughly doing information security for very large Fortune 500 American companies. I ran security at PayPal for 5 years, Charles Schwab for 10, and a large educational company called the University of Phoenix that teaches adults education after they're 30 or 40, after they've had 1 or 2 careers. And so I have been compliant all over the world. I have done a lot with encryption and protecting customer data. And I left these companies to come to the start of Sweetbridge to try and figure out a way to help improve the security of the world around this pretty exciting thing that's blockchain, maybe some crypto in there, ledger, because I believe that we forgot a lot of the core principles when we started doing all these very expensive projects, all these money-raising ICOs. A lot of the time, the world wrote a white paper, raised a lot of money, built an application, got hacked, and then thought about security. And that's not okay with me. And so I am starting to travel around the world and do talks and write more about how to put security back in the front, like banks already do, like big companies already do, and let's apply these same concepts to the projects that some of you may or may not be involved in today. I'm going to assume, and let me know that it's a bad assumption, that you all know what blockchain is if you're at a blockchain security talk on your own time. Is this a good assumption? Can I go with this assumption? That you all know what it is? Okay. So I'm going to give you 2 minutes with who Sweetbridge is, because that focuses my messaging and how I'm handling this space. I'm not here to sell you on Sweetbridge, so this is just informational only. What's interesting in the world today, and just sort of some background, is people who have been around a long time have gone through the internet bubble, the industrial ages back in the day, and now in 2013 to 18, this sort of rapid technology change that happened really is changing the world, right? The idea of blockchain, the idea of IoT, the idea of everything being connected all of the time, big data, it is making the world a pretty crazy place. How can we even hope to keep up, right? And we're not, right? We're seeing everything get attacked every day. We're seeing, all this proliferation of stuff. As the world has evolved, right? We went from the internet to social with Facebook, to sharing, with Drive and social sharing, and then we had the blockchain, which people are calling Internet 3, the value age. It's affecting transactions and all sorts of things. And what we're moving into is a world where all of this stuff converges all together. And what's scary as a practitioner, my point of view on this is every single thing that can break is all getting stuck together so it can break worse. Because it's an IoT thing plugged into an insecure application on a car that you don't drive anymore, sending data to people you don't know in a country that you don't live in. And you do that on purpose. It doesn't apply to this, but, and maybe it doesn't apply to Hong Kong, but 10 years ago, you would never imagine getting into a car with a stranger. And today, you call an Uber so you can get into a car with a stranger, right? These sort of concepts are changing the way we think and how we do and how we rationalize our money and everything. So what is Sweetbridge, right? So we're a company building middleware software that is trying to figure out how to get people to use their assets better. Your crypto assets, your house you might own, anything that we can determine the value of, we want to let you make money on that. Maybe you want to borrow $50 against your car for a couple of weeks. Maybe you want to borrow against your Bitcoin. Maybe you're stuck waiting for a big company to pay their bills because you run a shop on the corner, but you need to pay your employee, so you want to borrow a little money from your supply chain. So we're trying to enable that with our platform. My CEO believes that there are a lot of people in the world who are stuck in a really bad financial place. They have to borrow money at high interest rates. They can't pay their bills. They have to sell their inventory when they shouldn't. And so hopefully this platform will allow them to get money out of what they earn or what they own or what they have. And so when we figure out how to do this, there's a lot of information as the security officer, so I do risk, compliance, and security. To pull this off, I need to think about identity. Who are these people? Who are these companies? I need to think about what an asset is, where it is, what country it's in, which laws of the country I need to enforce. Because if I loan you money against your thing in Hong Kong, I have to have a way for you not to turn around and sell it, right? If I loan you $5 against the clicker and then I hand the clicker to somebody, that's bad for me. But if there's a way that I could stop it from getting sold after I loan you money, then I can loan you money. And this is one part of security and risk. The other part of security and risk is the technology part, right? And I'll get into that a little bit later today. So why did we choose to use the blockchain? Why is there blockchain in this company called Sweetbridge? What's interesting about the blockchain, and all of you hopefully know this, is it is a place where you can enforce the rules of the world legally and digitally. Assuming that it's legal in this country or your country, you can write a digital contract, assign it digital money, digitally send it to you, and enforce all the laws against that, just like you do with paper. The world runs on paper under the covers. And I don't know how much you guys know this, but the supply chain, when you ship something from China to Hong Kong or from China to the United States, there is this much physical paper that comes with it. Because the guy has to sign it, and then the girl has to sign it, and then they have to stamp it, and then it has to go across the border. There is so much paper in this system. The blockchain and all the companies that are working on this is starting to allow us to digitally recognize these papers, these laws. It's also a way to transfer ownership. As we have determined with Bitcoin, Bitcoin proved this. I can move some digital money from my wallet to your wallet, and you now own it. It's like handing a dollar bill over. It's the first time we've been able to prove somebody owns a piece of digital property that has a real-world ramification. So we believe the blockchain is the cornerstone for how we can pull off this idea. So to me, when I think about how to solve my problem with Sweetbridge, I take all of this stuff that's in life, and any project you guys do that touches finance, people's money, accounting, keeping track of things, is this legal to do? There are security, risk, and compliance ramifications of these things, no matter which kind of company you work for. And what's scary to me when I try to do this is that all of this now is one application that people are building across the globe as one full stack project. Right? There are now platforms out there, there are blockchain assets, there's blockchain loans, there's blockchain lending, There's all of these things out there that are combining traditional banking with traditional accounting, with traditional lending, with traditional assets, and they're trying to secure it all together. And quite often, these are people who don't know how to actually secure it. This is the Sweetbridge protocol stack, but the part that I want you to look at is when we build our economy, what Sweetbridge is you have a membership, which is identity and KYC. So we have the security of the person, the identification of who they are in the country they held a passport in or from, right? I need to prove I am Scott, I live in the United States, and I am able to transact legally, right? Then I have the accounting, which on BlockChain, when you write an accounting transaction on an immutable ledger, it is done, right? There is no undo button on this stuff. So theoretically, when I account an asset transfer, it is real, it is committed, and it is fact. I can believe it. Unless the information I wrote is wrong. So this is a traditional security problem, the CIA triad. Is the information good? Am I writing it with integrity? Is my source have good integrity? Because if I write something to an Oracle database, I can just update and change my name. But if I put my last name's Carlson, if I make it Smith, I might be forever known as Scott Smith on a blockchain, unless they write a second transaction on top of it that changes my name from Smith to Carlson. Right? These kind of accounting things where I move assets around are very important. And then of course, a wallet, right? People in this room know what a wallet means to you. Probably someplace you store your digital asset. To the rest of the world, a wallet is something you put in your pants and put your money in. Right? But in today's world, in the world of blockchain, in the world we're moving into, it is probably going to be a personal wealth history. It is going to be a listing of all your health records. So it's conceivable that your personal wallet is who I am, my identity, my health, the drugs that I take, where I live, the car I bought, who I owe money to. It's all going to be stored in my personal wallet because it will all be digital and it will all be assigned to me. And when I think about information disclosure, hacking, digital safety, like the bars of compliance and the bars of security start going up. And when I put this on a brand new technology that's getting hacked every single day because it's worth a lot of money, it starts to scare the traditional enterprise people. So let's talk about security now. This is why I am here to talk more about, I'm not going to go deep technical, so this is not going to be a how to code talk or anything like that. So I'm going to get a drink while you read this cartoon. When it comes to blockchain in the world, most people can't explain what it's for or why they're using it, other than my company needs a blockchain project because my boss heard about it on CNN. Or I want to fund my idea because I have a crypto coin and an ICO. Or I have an idea that will change the world because blockchain. This is how a lot of people start. And unfortunately, I've been in conversations that go like this. We want to use blockchain. Why? Because we want to. This is what happens in the crypto world when you do things without thinking about it. You start to lose people's life savings. You start to lose real money. This is not money from, the bank down the block. HSBC can lose $1 billion and the stock goes down and then it goes back up, right? This is people's money. They took real money, they bought fake internet money, and somebody stole their fake internet money. But because it came from real fiat to begin with, they're out. Like, there is pretty much, I don't know if there is one, there's no insurance policy for crypto. There's no insurance policy for your blockchain getting hacked. If you put money in a bank, I'm assuming it's the same in Hong Kong, if your bank loses your money, somebody gives it back. Like there's insurance at your bank. There's in the United States, I assume there is here too, and most places in the world. It doesn't work that way in the real world. The way that these things are getting attacked, the way that they're losing, they're stupid attacks. And it makes me sad as a security person that these are losing to stupid. And I believe if any of you have a job as a security person, you should never lose to stupid. And what that means, if you could use a scanner to scan your network and find the open port that the attacker scanned for, you should have closed it because you know better. We have been doing security in the world for 40 or 50 years now, back to the IBM mainframe. Almost all of this is the same. We know better. So, the public blockchain is different than a private blockchain. Quick audience check. How many people here are from an enterprise, a big company, doing a blockchain project, or you work for a big company? Anybody? No big company people? Maybe kind of? Okay. So there is a difference between using a blockchain inside your company that you have 100% control over, and maybe it's buried deep within your network, versus something in the public, which is, you know, Bitcoin or Ethereum or just moving around. Right? When you use public, you kind of use it and you need, well, peer pressure, but you don't want to use a third party. Maybe you're an anarchist who doesn't want to use a bank, so you want to remove third parties. Maybe you simply want to stick it to the man, remove the middleman. Maybe you just want a place to digitally protect your data. This is, you know, generally why people use a public blockchain. And it has really, really good math on it. I personally am comfortable that the PhD mathematicians have written very good math to protect a public blockchain. Until we have some more sophisticated things that break those algorithms, you know what, they're pretty good. But again, when you look inside your enterprise, people don't go through the simple flowchart. Do you need a database? Yes. No? Okay, you don't need blockchain. You might have seen this. How many do people need to write to it? Lots? No? Okay, you don't need blockchain. Do a lot of people trust each other? Inside your company, they all trust each other? Yeah? Then you don't need a blockchain. So why are all these enterprises doing a blockchain project? Because you need a press release, and you need to do something on a blockchain. Right? That's kind of where a lot of people are doing these today. And this is funny and silly, but this, to me, shows why we're bad at security on this stuff. It's because we put the cart before the horse. We bought the technology before we figured out if we need it. We installed the technology from source on a server in development. We know better. Alright, so now the real meat part. So to me in my brain, and this talk is 100% Scott Carlson's brain, feel free to interrupt and ask questions, feel free to challenge this stuff. I don't claim to be right, I just claim to be opinionated. So, I think I can break down a blockchain project into 3 primary layers of thought. At the bottom is the blockchain itself. You need some kind of actual software that will store your records. Most people use Ethereum, but then Neo Cardano, and there's what, 30 others or something. And then you have the logic layer that actually does the work. It holds the keys, it does the logic, it writes to the chain, it does most of the work, right? This is the part in the public, if you mess up, money goes away.
Someone's going to fall over taking a picture. Can you just reassure everyone's going to get your slides?
Everybody will get the slide deck.
Right, don't fall over.
Yes.
Okay, cool.
If you would like to take a picture of me, I will.
Good.
When you get in this level, especially with keys get scary. Because one of the things that people who've lost money realize, if you have the key, you are God of the transaction. You rule it all. So you have to decide, do I need multiple keys? Do I need multiple signatures? The safety deposit box at the bank has a key, not 2 keys, not 5 keys. If you have the key, you can get everything out. Same kind of thing with the blockchain. Is that appropriate? And then you have the stuff that faces the person. The website, the interface. There's actually another layer, which is the human. The human is actually the biggest problem in the world most of the time. Because, and I probably quoted this a lot of times, you can't fix stupid. You can't. No matter how secure you make something, a human being will figure out how to mess it up. I believe this. So you either have to accept the risk of that or try to design it out. But as far as I know, there's no system ever built that can design out human error. You can just try to compensate for it a lot. So my belief when it comes to attacking blockchain projects, and this is what you'll hear for the rest of the talk, is you don't attack the actual blockchain. If you want to build a quantum computer and break the math so that you can break into the blockchain, great. I know some scientists at IBM are trying to build this. As soon as they get to 32 quants or whatever they measure that stuff in, they'll win. But that's not where I would start. I'm going to attack the person. I'm going to attack their machine. I'm going to attack the applications. I'm going to attack your contracts. Because it is so easy to log in when you've left the password admin, then a open source tested, mathematically secure piece of software that 1 million people use and some really smart people in the world have looked at. A couple experts out there, Checkpoint, if people know who Checkpoint is, they're an Israeli cybersecurity company. They think that crypto crimes and attacks will exceed every other cyber attack this year. People, the bad guys play for real. When they hear crypto, dollar signs in their eyes. When they hear blockchain, they know where to start. So when you look at why people want to be bad in the blockchain and the crypto space, it's pretty obvious, right? Bitcoin was worth $18,000 and it was 10 cents at one point or something, right? There is a lot of money. Ransomware, crypto hijacking, IoT, right? It is so easy to break into this stuff, right? You can do a lot of bad things with this. What's funny about the bottom two, just a quick side note, is even though we're using blockchain, people don't really believe it will help. They're just doing it because. And when they mess it up, they're going to get sued. But we're taking the business risk without putting the security controls in place. So, my point in every conference that I talk to is because blockchain has a bunch of applications on it, every single attack that we have ever fixed as a security person ever needs to be refixed or revisited on the blockchain. We cannot forget all of those things that we've spent the last 30 years learning. Let's talk about the chain itself. So generally, when you're rolling a blockchain internally, you download somebody else's code. You likely don't write your own. Pull math libraries that everybody has already tested, and you download some worker nodes to do your validation. And these are all pure and tested and probably pretty good. It's very likely that this stuff has been used in the public, and it has been very thoroughly reviewed by nation states and governments and PhDs. It's probably pretty good. I would say you can mostly skip doing your own tests against public release code. Like if you're putting Hyperledger in your network, unless you're rolling in alpha, IBM has probably done a better job than you in testing their Hyperledger code. If you are the best developer of the language that Hyperledger is written in, maybe you will find a bug and you can submit that as a bug bounty. But I'm guessing you wouldn't be here listening to me if you were the best Hyperledger developer. Usually the core is safe from single attacks, unless of course this whole funny 51% thing that's taking over the world. For people who are unaware, most blockchains in the public domain work on a model where a certain number of nodes need to agree on what to write in the next block. When they all agree, they write it. But if you, the bad guy, own more than half of the network, you can control what's get written. You can shard the network, you can split it apart. So theoretically, you could give Scott a whole bunch of money and then quickly say Scott didn't give anybody the money after it was transferred. A lot in the public, Bitcoin, Ethereum, and some of the other small coins, there are crypto miners who have built hardware and they own more than half of the nodes that verify the transactions. So they could game the system and steal. Not saying they do, but they could. If you are building a project that has its own blockchain and somebody is mining your coin and they own more than half, you need to worry about this. That's hundreds of people on the planet, though. It's not very likely not the people here in the audience. When a transaction is written to the blockchain, it's committed and encrypted. As far as I know, unless a project has written its own mathematical encryption library, that stuff is not able to be changed. There is no mathematical way to fake the hash of that block that was written. I believe, with my computer science degree, who's kind of good at math, that the encryption there and the data that's written there is safe. And your average security person can skip it and move on to the next more important thing. At some point, quantum computing will catch up. People who are in the older end of the room, we've gone from 16-bit to 64-bit, we've gone from 128 to 256 to 2048 to 8192. At some point, computers get faster than the number of bits. But for a while, it is safe enough. So today, there's nothing that can break it, so I shouldn't worry about when something can break it. Because when something can break it, then I'll fix the math. So this is, again, another thing you need to maybe think about for a second, but can just skip. When you think about scientifically immutable, so immutable, just to make sure everybody understands, it cannot be changed once it is written. It is written once and then read forever. You can't update. You have to write a new copy for immutable. There are some things in life that immutable is good. Some things that are bad. Maybe you get married and you want to be divorced, so you don't want your marriage to be immutable. You want the ability to change the state of it. Bad example, bad joke, but own a house, you want to sell it. Own a car, you want to sell it. Anything like that, you don't want to be immutable. You want it to be fixed for a while, but you want it to be changed. There's a couple of, I'll let you guys read this stuff later, but there are a couple of attacks on the chain itself. Double spending attacks on the chain, hash attacks, vector attacks, all these things where you essentially, DDoS and overwrite and work on the chain itself. There are people who make it their life's goal to break into the chains out there, and they are really, really good at this. And I'm not going to pretend to be able to give justice to the ability to attack the chain. In almost every case, what they are trying to do is write a record where they get all the stuff, gain to show that they didn't really get all this stuff. That's essentially what all these attacks are trying to pull off. This is an eye chart. I'll let you read it later if you want. Something that is far more interesting are the concepts of the business logic and the smart contracts that write the actual stuff to the chain itself. When you think about your smart contract, you need to look at a lot of things, right? This is the make or break part to many, many projects. If you are recording your transaction on a blockchain itself, your contract is the thing that does the logic to move the money around or write the asset ownership or update a record. The number one thing in the crypto world is often the double spend attack, which is like if I hold a dollar bill and I hand it to you, you have it now, right? I can't give it to somebody else. That's the traditional use case. But in the digital world, we all know, if I make a digital copy and give it to you, then I can make a digital copy and give it to you, and make a digital copy and give it to you. Like movie pirating, I can make as many copies and give everybody a copy, and it looks like the original. Contracts who have logic that says, Scott, we'll send it to Kent. If there's a way to intercept that workflow and send it to the wrong person, or send 2 copies to Kent instead of 1, that is a bad logic flaw in that double spend equation. The vast majority of smart contract problems are, I guess, man-in-the-middle logic flaws, or calls where you can change the intended focus. When I had our smart contracts audited at Sweetbridge, we had to talk about how do we secure who can execute them? How do we know that there's not a break point that I didn't intend? A if-then-else breakout. Like, if it crashes, what happens in the middle? If it succeeds, I get the intended outcome. But there could be things like, if this weird environment variable, then something. You can change environment variables, right? So when you think about multi-spend, you have to go through these use cases. Wallet addresses is something that we've probably all seen, which is, hey, send me money for my ICO, but somewhere along the way somebody changes the wallet address and instead of sending you the money, I send him the money. It was either, I mean, there's been a lot of examples of this. 4 examples. Example number 1, there was a company who wrote a contract and somebody overwrote the contract with a different address in it because they hadn't secured their contract with who could update it. And thus the money went to the wrong place. The only thing they changed was the wallet address. So that was an insecurity of the contract language, as well as permissions of who could update that contract. There was a very big recent attack with My Ether wallet. People might have heard of this, which was actually an attack on the routing on the internet. They took over BGP, it was called, Border Gateway Protocol, and they routed a bunch of traffic to a server that it didn't intend, and then humans were stupid. What's interesting about this attack is it wasn't really an attack on the wallet. It was an attack on the internet. What happened was when you opened your My Ether wallet, it was routed to the bad guy's server. So they had control of where the money went. It gave you an error message in your browser. It said, this website is insecure and the certificate does not match. But we all as humans, what do? Ignore, 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 ignore. Right? We've all been on an airplane. We've all been at a hotel. We go to an open kiosk at Starbucks and our mail says, unable to get certificate. Would you like to, ignore, ignore, ignore. We don't even read it anymore, do we? I mean, unless you're really diligent, you never even read it anymore. And so this is not My Ether wallet. Are you sure you want to go here? And all of these people said, yes, I still want to send the money. And then the money went to the bad guy. Right? I don't know if this is the human's fault or that blockchain and wallets aren't grandmother proofed yet. I'm not sure. Logic flaws in contracts are not really a security problem.
You need to explain what's grandmother proof.
Grandmother proof.
Yeah.
Okay.
It's a good story.
So my grandmother is 98 years old and cannot even figure out how to use an iPad. Because she doesn't know how hard to push the button or how hard to tap or swiping and moving. I don't think she would ever have an iPhone with a crypto wallet on it or an external ledger to do her banking with. It's not grandmother. And in fact, when I got a job as a security person, my cousin was worked at World Vision International, which helps after hurricanes. He had told her his job was fixing typewriters because he could not explain to her what his job was. So when I told her my job was securing stock trading, because she knew what stock trading was, she said, "That's awesome, your cousin Brian fixes typewriters." That's kind of like the same thing. So she comes from an era where, she was born in 1912 or something, right? There's barely electricity. The world that is securing this right now is not my grandmother proof.
What does it actually do?
Hmm?
What does your brother actually do?
Oh, so when there's like my cousin,
Your cousin, sorry.
when like there was a typhoon in Haiti, they fly a helicopter in and drop a data center, and he sets the data center up to allow all the relief workers to communicate with each other.
It's not a typewriter.
So he does that kind of thing. It's not typewriter fixing, right? It's quite more complicated. But back to this, logic flaws. So when you write bad flowcharts, I don't know if that's a security problem, but it sure sounds like a security problem to your bosses. And the problem with people who are writing smart contract language, a lot of this stuff is written in a programming language that was invented to do this. That there are hundreds or thousands of people in the world that are good at. That as far as I know, there is no enterprise-grade security scanner for. There's a bunch of startups who have written their own stuff while they were learning the language too. So there's a bunch of people who learned it better than you, who are scanning your thing because they think they're better than you. And this code is doing logic to move billions of dollars around the planet. It's likely to need a code review and a flowchart review and a tabletop test. People who are security, are there people who are pure security people in the room here? Okay, so you've done a disaster recovery tabletop test sometime in your life. What do we do when this thing breaks? We do this. Who are you going to call?
Ghostbusters.
Your logic of your contracts need that kind of flowchart walkthrough. I guarantee you need to say, if the money comes in, then it goes over here. Is that what we intend? Yes. Okay. Is that what it says? Are there any ways to cheat that? If this variable says Scott, then send the money to Scott. Is there a way to change the variable by the wrong person? You have to go through this flowchart one at a time in your contract logic. Sometimes the contracts are safe, but you can update them with insecure calls to the contract, inappropriate permissions to it, or the ability to update stuff on the edge. And this is where key management comes as well. People on the block who have a blockchain project, in order to write to a public chain, you need a key, right? You have to have your private key that allows you to write as you. In the world of banking, there are very secure ways to hold keys to things. Hardware HSMs, hardware storage modules, sometimes there's software ones, sometimes you can put them in the cloud. We really haven't matured the infrastructure backbone to manage these kind of private keys. They are very often generated on a developer laptop, sent through Keybase to another guy, uploaded by the infrastructure person, and then duplicated across your cloud. There are 3 or 4 ways people are copying these around, unless you're super safe about it. And so when it comes to looking at your middleware layer, I'm not going to tell you what to do, but these 5 areas are the things that I have seen people mess up the most? In my company specifically, we found a couple of logic flaws in how we updated the contract. Somebody could have stolen a credential and changed our entire contract. So we had to fix that. We hired a professional tester who was like, hey, last time I broke in using this, I bet you it would work here too. And they won. I guarantee that unless you are one of the best Solidity or whatever developers on the planet, you will not catch your own flaws. This is maybe venting as a professional, but I have met a lot of people who are very egotistical in the blockchain world. Maybe because they're rich now, but most of them think they're smarter than everybody else. They couldn't possibly make a bug. They couldn't possibly have a logic problem. And maybe they have their coworker to look at their stuff. But their coworker was with them the entire time, so their coworker understands what's going on. They don't think about the edge cases. And some of this stuff is edge case problems. Some of this stuff is thinking like an attacker. I don't think enough of us think like a bad guy when we write our code. We think, this is how it's supposed to work, and it works great when it's supposed to work. There are concepts in the world, mostly called fuzzing, where you essentially try to send all possible input to a form, or send every possible permutation to an API, just to see what happens. What happens if I do this? What happens if I do that? What happens if I put a Cyrillic character in an English field? We had a really interesting, and I'll talk about this in a minute. Okay, let's move on to applications. So the part that humans access are probably on the internet, which means everybody on the planet can mess with it. And they're used by humans, or bots, or robots, or your camera that was taken over that's attacking it. If you have an open form on your website for somebody to type something in, then it can be abused. It's pretty funny how, some of our, this Web 3.0 world, right? There's React, and there's Node.js, and there's HTML5, whenever you're writing all this stuff in, and that probably calls a back-end API. And a lot of the people that are writing this stuff do not have formal training as a developer. They took a Udemy class, or they, went to some training course on the block, or they learned it themselves, and they're writing a web interface. I've run across a couple of forums in our development environment, thankfully, where we did no input verification. It said, input your national identifier here. So we expected people to type numbers there, because in the United States there are 9 numbers, and you submit it and you're done. But what happens if I put 50 numbers there? Well, it crashed the database, actually, is what it did. What happens if I put Russian characters there, or Chinese characters there? The form broke, because it didn't know what that character was. What happens if I put backticks? It didn't submit. Some funny problems that are, these are kind of logic problems. It's kind of you should know better, but they turn into security problems. When were you born? I was born October 21st, 10-21- in the United States. In the rest of the world, it's 21-10-, because you put the day first, not the month. Like, all of these things break your system, and that turns into a denial of service, which turns into a security problem. What's funny about some of this stuff is in the history of security attacks, sometimes the bad guy just wants to break it so they can attack it while it's rebooting. You DDoS the front door so the back door turns on. You DDoS the back door so that the people aren't looking at the front door. You submit stuff into the form 200 million times so that they don't notice the one that you typed in that you're actually using. One of the really interesting things about gaming the front end is you can cause so much noise for a security operations desk that they will miss the actual attack. You're going to start throwing away application logs if it's full of noise and junk and fuzzes and botnet attacks. In traditional enterprise security, and this is really not the blockchain part of it here, but you protect against all of these kind of attacks through code review, static and dynamic analysis, web application firewalls, all these sort of traditional security things. This applies to your blockchain project as well. If you're a tiny company writing an application that wants to just change the world, you don't have enough money to buy a fuzzer. You don't have enough money to do a dynamic analysis. So you don't. And often they don't even do the basics, like make sure your national identifier has to be 10 characters and only numbers. There are free code samples that do testing of most of this stuff, quite honestly. You have to at least use this. So the humans is hard. Most of these projects have humans that use them. And when you think about ways to break into a human, it's actually pretty easy. Phishing is the most common thing. People have heard about this. What is the easiest way to get your password? Is on Singles Day, I will send you an email that says you have just bought this thing. Click here to see when it will get to your house. Or whatever they really say, because I've never bought anything on Singles Day. But I assume the email says something like that. Is that right, Chinwan? Does it say something like that? So you click on it, and the local delivery company usually tells you when it will be at your house. But instead, it sends you to a drive-by download malware site. And it installs some bad software and steals your password. The #1 attack day in the United States is December 20th, which is the last free shipping day that Amazon has in the United States to still deliver your present by Christmas. The United States Postal Service, UPS, and FedEx deliver 99% of the packages in the United States. So if I send you an email that says, your package is on the way, you're barely going to look at it, and you're going to click on it, and then I win. I just installed something on your computer that stole your private key to your wallet, or watched your password on your banking website. So when you think about how do I fix the human, some of you might be rolling out an application to a telephone, right? An iPhone app. Do you trust iOS? Do you trust Apple? Do you trust the fingerprint? Do you trust Face ID? Most people do. Do you trust SMS? You trust it more than not SMS. If you had to choose between not having SMS and having SMS, you should turn SMS on, because it's better than not having. If you have another choice, which is a widget in the app, you turn that on instead. But these things need to be thought through with how negligent can people be? I've used the word stupid too many times. In almost every case, in almost every enterprise breach and theft of people's money, it started with, I sent them a phishing email, and I stole their password, and I logged in as them, and then I did something. Or maybe I guessed their password because they didn't change it. There are very common things you can do to your users to make them set up things to log into your application. Again, this is not blockchain related. But if you're the brand new blockchain company to store housing records in Hong Kong, and you never made the users change their password from the one you sent them an email, your blockchain project is going to look really bad. And all the money you raised might go to lawyer fees because you're going to get sued. Key management in the blockchain world, and it's probably time to talk about it, is a really hard thing in my book. Most human beings are not capable of doing their own key management. We all probably have lost our car keys, or our apartment keys, or our safety deposit key, or the password to our bank account. But in every single case, except maybe if you own a Ferrari, you can go to the car dealership and get a new key and still get in your car. You can go to the landlord and get another key, or the locksmith can open the lock for you. In the crypto world, and in the world of blockchain, and in the world of keys, it's almost always one and done. So we have invented things like passphrases. You type in the 24 words and you get access back. Unless you lost the piece of paper that you wrote them on at 2 in the morning when you decided to set up your digital wallet. So then what do we do from there? We maybe take our spouse and we make a multi-signature key, which is either me or you can sign it. Well, now 2 of you have to lose something, and that's a little bit better. Maybe you have 2 of 5 in a company. Maybe you have 5 of 10 for something really important. There were some really big attacks for wire transfer fraud that happened a number of years ago. I don't know, people in the banking world. You used to be able to wire money at a bank. Everybody knows what a wire transfer is, right? Most financial accountants could control the wire transfer account. And many of them did not have a limit to how much money they could send. And it's really easy to attack somebody low on the totem pole, a basic analyst, when you promise them praise. Hi, I'm your boss. I really need a favor. You'll look so good and I'll promote you if you just help me this one time. People will totally give you anything if you praise them and look at them and be like, I will reward you at work if you just help me this one time. And there were hundreds of millions of dollars wired out of companies because they socially engineered people with the keys. So not only do people lose the keys, but they misuse the keys. I don't think we're at a place where it's acceptable. Yeah, I have a hardware ledger somewhere in my bag here. And I use it kind of because I have to. But I hate it. There's no way I'm going to go to a bank and dig out my thing and plug the cable in and do the fingerprint thing. Like, it's not convenient. There's a couple of weird trains of thought depending on how your project's getting built. A decentralized project or a centralized project, right? People might know the difference here. In centralized blockchain projects, pretend you're a bank and you're doing a blockchain project. There's no reason you can't be centralized. There's no reason you can't keep a copy of everybody's key. You already keep a copy of everybody's passport and bank account and safety deposit box key. Maybe you keep a copy of their crypto key. And I'm bringing this up because if you don't think about it all the way through, it turns into a security problem. At Sweetbridge, there is no way that I can let a supply chain company be unable to receive their shipment because the secretary lost the key to the wallet. Like, that's just not okay in the world. To lose one key and all of a sudden you're out of business. It's not okay. It's a bad business risk problem and it's a big security problem. I also don't want to allow somebody to take the key and steal all the inventory. That would be just as bad. We have proven with fake internet money being stolen. Sorry if that offends you.
Yay, fake internet money, thank you.
Yeah. But it's ended up making the bad guys rich because they have sent your inventory to some place it shouldn't be. So I am, I don't know, making up a new thing that I'm going to try to start fixing as the idea matures. People who do security might know about this thing called the SANS Top 20. And what it is the 20 most common things you should always do at a company when you're thinking about security. And I believe, until somebody corrects this, that you have to do those same 20 things in any blockchain project, with a few tweaks, depending on the code base and what you're doing with it, and if you're working with assets or money. People who have done security know about scanning and patching and changing your passwords and rotating your keys and changing your SSL certificates. But you know what? In a blockchain project, especially in this brand new raising money ICO world, you buy a .io domain and you get a free certificate that you never rotate, and you leave the password of WordPress admin. Because your 5 contributors need to go update stuff. The first thing the attack bot is going to use is admin. So looking through this list, I won't spend too much time on much of it because you can all read it and you all probably know. It's mostly common sense. Know where your stuff is. Configure it with the security defaults, not the easy defaults. Scan for vulnerabilities, or use the most recent copy of the code. If you have a project where you downloaded an open source library 2 years ago and you have never checked to see if there's a new version that has fixed a security problem, please go check to see if there's a new version when you get back to work. There are some, I'm totally forgetting what it is, but there's a repository of Node.js libraries where you can download all of these things for your projects. There are now security scanners that look at your code and say, you're using these 20 modules. Hey, there's a new version of them. You should download it because it fixed a bad security bug. Right? So you knew you were using Node. You knew where it was. You scanned it. And then you're going to patch it, right? It's the same kind of stuff, even though it's blockchain. Imagine that. Application security is, it probably should be at the top. Blockchain is a bunch of computer code. It's not hardware, I don't think. I don't think there's a hardware blockchain. Like, that's only in hardware. It's a bunch of computer code that some smart people wrote. It's compiled and installed somewhere. It is an application that writes a bunch of stuff with math. That's kind of really what blockchain is. And then it uses some logic so that everybody agrees that what you wrote was accurate. The math for some of this stuff, the ledger stuff and the math part, it's been around for, 30 years in some case. There's scientific papers on proof of consensus and all this. But it's written as an application and you're not scanning it. Malware's good, secure networks, right? All this stuff. There's been some really bad things I've been seeing in the deployment of these change. Some people might have seen now that Microsoft has a blockchain kit on Azure. Amazon has a blockchain kit on Amazon. You can download Hyperledger project and spin it up. There are VMs that have a full chain and a full node in them. If you download that for your project and you never change it, the entire world knows how you have it configured. Because they can go download it too, just like you did. Far too many projects are just building a server on Amazon, installing some code, and letting it run like that. They're letting their customers upload documents into the open Amazon directory, and it's getting breached. These are not blockchain problems. These are security problems, right? And storing what kind of data you store. This is quite often a security problem in that there are laws, for instance in Europe, GDPR, that require people to be able to delete their data or opt out of you storing it. And theoretically, if you put all of my data on blockchain, it's immutable, and if I ask you to delete it, you can't. Right? Are those two things together? It's one of those decisions you need to make when you're rolling your project. Code securely, monitor. Like, this stuff is common sense for security people. That's the last slide. So, I'm going to get some questions, but I want to go through this again. Here, very specifically. To me, security of the blockchain kind of has nothing to do with blockchain. I'm sorry if you were led to believe that I would talk about code and ways to manipulate it and attack it. I can talk about that if you want. But it's mostly irrelevant, because that's not how you will lose. You will lose because your person got breached, or your interface got overwritten, or your contract has a logic flaw. Is this a blockchain problem? No, that's just what you called your project. You called it a blockchain project. But remember, that is just an application that we have called a blockchain. Just, ledger. And it has all the same stuff as every other software project we have ever done, ever. So it might have a different word. Smart contract is computer code, written in a language. Keys are keys, passwords. We've done it all the time. Right? End user interfaces. We've been testing these since SQL injection was a thing. Right? The new SQL injection is writing bad stuff to the blockchain, which is actually better for the attacker because you can't update it now. I still think that one of the best attacks you could do in a blockchain project is you could change the data so that everybody's name in Hong Kong was Shu. Everybody's last name is now that. Or Carlson. Everybody in Hong Kong now has the last name of Carlson. And you all get your bank statement, and it says Kent Carlson, Scott Carlson, Jin Carlson. And you go, that's not my name. So you go to the bank and you say, this is not my name. And they look at their system and they say, yes it is. It says right here in the immutable ledger that that's your name. And you pull up your passport and you say, no, it's not. And they say, well, yes it is. Obviously we didn't get it wrong. How do you fix this? How do you fix an immutable thing? I think that's going to be a very funny big attack one of these days. Because it's going to be a data problem and it's going to be permanently recorded somewhere. A lot of our projects on the blockchain don't yet have a real world way to fix it. One of the great things about the planet is there's always somebody you can go ask to fix it. If the bank messes up, you go talk to the bank manager and you say, look, what do I need to do to fix this? And humans work it out. When you start talking about devices that permanently record to a piece of software that uses it to make decisions for your life, there are no humans that can fix that. Your car will drive you to work based entirely on robotics and GPS and IoT, and it might store your route on a blockchain. It might one day in our lifetime do that. I mean, I think, does the MTR have a driver? There's no driver, right? There's a control desk. There's no driver in the train, is there? Is there? Because they need to push the stop right now button, right?
Yes.
Okay, but that might be the only reason they're there. They don't accelerate it and slow it down, they're like the emergency. Because a human needs to be there to override it.
Yes, for incident response system.
Right. This stuff here in the middle that makes all your logic decisions doesn't have a human in the way. Is it important enough where we can remove the human? If you do remove the human, you better look at it like you can trust it. What else do I want to mention? I don't know, maybe that's it.
You're scaring everyone.
That's the point. Should I smile more? Boo.
Yes, as Brian Bellendorf said, garbage in, garbage forever, right?
So I have been accused of not smiling enough and being happy about these kind of things. But when there has been $1 billion stolen from human beings, I get upset. I love talking about this stuff. And I love trying to figure out how to break things. But I don't want us to lose anymore. There's a lot of funny stories about how people have messed up, and it's cost them billions of dollars. But what I do know about this is the math is good, the code language is good, it's humans, and come on, this one, humans and implementation, that is the problem with this. And I think that's where our biggest problems with blockchain projects are. And if I needed to secure my blockchain project, I would start with all of the simple things. And that really is the message I want to leave everybody with today. If you have skipped the first 20 things, please pause and rewind and think about the basics before you go any farther. And please don't transact money or real estate without making sure somebody can't steal it. At least as much as you can possibly do. And with that, let's take some questions.
Okay, two questions. One is, what is actually blockchain Sweetbridge based on?
Sweetbridge records this information on Ethereum. Internally, we use no blockchain inside the company. We use Postgres because blockchain is not fast enough. At some point, we might use Hyperledger and Hyperledger Indy to do identity and fast transactions. But we're not there on the inside yet.
One more question. Do your system have a social recovery? As you say, the people is stupid and they lost their private key always. So how did you figure this out?
We have not implemented key recovery yet. Our wallet alpha is out, and it requires you to generate a key like normal, or implement your current wallet key that you already have. In the next version of our wallet, I am arguing that we must become a key custodian, because I apply the grammar rule to most secretaries or warehouse workers at supply chain companies. I really wish I knew the Hong Kong market more. But the shopkeeper at the end of the block buys things from a distributor to stock their shelves. Very likely there are a lot of people who run stores here who are not technology savvy. They cannot manage their keys to the money that brings their goods in. I wouldn't let them, it seems bad. So I'm gonna have some kind of key custodian thing.
Yeah, basically some kind of CA, still back to the basic.
So, yeah, what we're trying to figure out is what the best global strategy for this is, though. There are some projects, and this is where you get into sort of the new projects. I could be a custodian, but then that makes me legally liable if they get stolen. I don't have that much insurance. I could make a bank liable, right? There are projects that allow people to be custodians of things on your behalf, like your bank. Most people trust their bank. So if your bank held your wallet key and you could go reprove your identity, maybe that's where we should put it. Maybe we should write them all to a safety deposit box periodically, right? These are one of these things because we're also a startup company. I have to make a right now decision, and then I have to make a future decision. So the answer is we haven't solved the problem. Because we're trying to do business in most countries, we have to figure out how Hong Kong wants to do it, or how China wants to do it if it's different than Hong Kong. Right? It's really, really hard. And this keeps going because China as a country, when you do technology in China, especially encryption, as an enterprise you're required to supply to the Chinese government the algorithm or the key so that they can inspect it or look into it. Which is fine if you're a Chinese company governed by the Chinese government with Chinese citizens. It's not okay if you're a UK company trying to do business with a Chinese company. I'm not going to give them my keys. So how do I let them inspect it and recover it when I can't give them the keys as required by law? So this is a hard problem to fix. I think the answer right now is what people like Coinbase are doing, which is key custodian for the people with lots of money. I really think the answer is going to be some bank. HSBC is going to say, I'll do it. And they're going to first do it because their market share is down and they want to win back some market. And they're going to build something for you to upload your key for storage. I really think that's what's going to happen. Most enterprises in this space, and this is a very long non-answer to your question, big enterprises are waiting for all these startups to fail, in my opinion, so they can adopt the best thing that survived. And then they will use their market presence to do it the right way. We're all failing around the world, and then in a couple of years they'll do it. Question?
Second question, in the Sweetbridge, do you have some special approach for testing smart contracts?
Our approach to testing smart contracts is the same as everybody else's. So we started by hiring some really smart people in Switzerland who have been doing smart contracts for years. We have had it audited by 3 professional companies who are also known security testing companies. I can refer them to people if you're interested. But we have had a vulnerability test against its execution if it's running. We've had a code review. We've tested the logic on the testnet. And every major release we're going to test it again with whatever validation things there are. As far as I know, there is no really good way to do abuse testing on your contracts yet. So that's what we do.
So what's your idea or suggestion for ICO project? Whatever already raised for 30 to 50 million, except for multi-signature. What else angles?
So they have to control their own money, multi-signature. That's the given. There should be people not associated with the project also on that multi-signature.
As you mentioned, as a bank
Something. Trusted third party.
or law firm.
Yeah. There's some interesting legal things about it. So the people who started an ICO are either family or friends or colleagues usually. Right? They're 3 or 4 very closely related people. The thing about having 3 of those 4 trusted people is that they'll just collude. You can't solve collusion when everybody trusts each other and started the thing together. So if they all want to defraud it together, they win. Right? Husband and wife, one or the other, well, they're both going to steal the money. Right? So maybe it's your insurance broker. Maybe it's your investor partner. I don't know. Maybe it's your mom. My mom won't let me steal the money. She won't approve it. Right? I don't know. So yes, multi-signature with a third party, that is the decision maker of whether it's a good decision. That's good advice. If you can't afford anything but a bug bounty, run a bug bounty. I didn't talk about it in my talk, but there are some wicked smart people in the world, and some of them are really good at one thing. When I ran security at PayPal, we ran into this guy who was really good at Java root exploits. And we'd roll a new Java thing and he would come up with a new buffer exploit. Every time. He was some PhD teacher somewhere. But he made money on the side by breaking into Java. And he was like the one guy on the planet that was that good at it. So at least take some of your money and say, $1 million bounty. Here's my thing, break into it. Because you don't have to pay a tester, people test it. And it's really not that expensive depending on what you have. One of the mistakes a lot of ICOs make is how they deploy their thing. Unless you're a big platform project, most get developed on a laptop or a couple of laptops, and then they get integrated on a different laptop. And so your whole stack is in one virtual machine. And then to deploy it, you copy it onto a server and make it work. So your entire stack is on a server. Unless you're smart enough to use Docker, unless you're smart enough to use microservices, unless you're smart enough to do software-defined networks. All of these people have very likely built for convenience because they built the whole stack with just a couple of developers.
Yeah, maybe they can develop under the VBI. That is the way to prevent all the whatever the policy, and as well as you can maintain the role-based security assurance.
Some of it is
Yeah,
that way.
something like that. That actually I saw that they're doing this.
So yeah, so if the project is like that, then you have to control the perimeter and make sure nobody can get in, and then look at plans to break it apart. Because you want to protect against catastrophic loss. You want to create a backup for disaster, so make a copy of it. You definitely want to change all the defaults, and you want to protect your money. And then maybe the last thing is you want to, if you've done a token drop, all these things that people have invented, airdrops and token drops and sending tokens out, and you want to make sure the people who invested in you actually get what they promised. So don't send it to the wrong place. And that's a really big thing. Use the telephone, use email, verify. A lot of token things are skipping the verification step. People might be familiar with Telegram, right? And you can join a Telegram channel for a project, and sometimes they say, "We're selling more, send your Ethereum to this wallet." Please don't ever trust something like that. Remember the rule? If it's too good to be true, it is. Yeah. So, if it was too easy, it was. If it was too easy, follow that rule.
We probably second additional security layer, something like that, and something multi-factor authentication
Sure.
on top of that. That will be
If you have a front end, and
and that will be ensuring that that kind of the identity authentication, that because it's own, it means your identity, right?
Yeah.
Something like that.
yeah. Shoot, the thought went. So Sweetbridge hired me as a CISO, right? Sweetbridge wants to do business in the biggest 10 economies on the planet. I happen to have weird skills about being compliant because I worked for PayPal. That's why they hired me, because I do security, compliance, and risk. If you're a ICO project, you probably can't afford a security person, so rent one. There are hundreds and hundreds and hundreds of companies that you can rent a security person. If you're big, you go to PwC and E&Y or whoever. If you want to call your buddy who's a security person, rent them for a while and pay them $100 an hour, $200 an hour, whatever.
And normally for security contract audit, the average package or the fee.
How much? One independent guy wanted $3,000 per contract, five Ethereum per contract, so that's pretty cheap. Another company that quoted me was $100,000 for a full stack audit, $100,000 US dollars. So what is that? $800,000 Hong Kong dollars. I know the big ones, these billion-dollar ones, Neo and all those. They've spent millions and millions and millions and millions on everything. So I mean, if you've really raised $30 million. Take 10%, stick it over here for security.
At least.
Up front.
Does Hong Kong law recognition the ownership transfer in the Sweetbridge?
So, money is easy. physical money is easy. Crypto is commodity or asset, so that's easy. Cars and stuff you own, your personal property. Property, we're not going to talk about. It's really hard to determine ownership of certain things around here because you rented from a person who got it. I don't know how Hong Kong property law works. So that part's hard. Supply chain is easy because I take this and give it to you, so I owned it. Cars and stuff are easy and money is easy.
So how
in
did you
terms of
connect maybe the stock between the Ethereum? How can you connect?
So,
What's the question again?
how do we connect? Okay, so let's talk again about what Sweetbridge is. We're an alliance of projects. We are building the middleware layer. We are trusting other people to figure out if it's legal to do asset ownership. We are trusting other people to do identity. We are trusting other people to do asset transfer in some cases. Because we can't be legal in every part of the world. We just can't. We don't have enough money. So we're working with people like Materium, who is trying to study the laws of how to do digital ownership. I think it's legal in Hong Kong to use a digital contract to buy something. I don't think you need paper. I don't know if anybody knows if that's true, but I think it's okay in Hong Kong. And that's the first step. If you can't recognize a digital contract, you can't put it on the blockchain.
Yes, that's true.
Right? And there are a lot of countries in the world that still require a wet signature when you're all done. You still have to go to the bank and show your passport.
Yeah, in Hong Kong actually, as far as I know that, some legal firms, they accept they're using document sign.
Yeah.
Yeah, that is
DocuSign is legal.
Yeah, that's legal.
It's
So
okay.
basically, there will be a way to digitize and plug in that
But
on the middleware.
Can you buy a car with DocuSign? I think so.
Not for property though. Property no. Unless they change the law. The laws would clearly have to.
So you can't do property transfer ownership.
Not in Hong Kong. Right?
100% digitally in Hong Kong.
Not in
So
Hong
so Sweetbridge can't allow you to borrow against your property because it's not digital.
I think the Hong Kong right now, as far as I know that it means you cannot the flat currency against, in between of that exchange at the moment. So basically, all the ICO company in Hong Kong, if they're based Hong Kong, what they get, they must be getting token to token. That is no any.
Sometimes you can put money in the bank, but
Yeah, I mean, if you are really open the ICO.
yeah. So
Yeah.
in the world of fake internet money, there are no rules.
Yeah, you can get money.
You can invent a token and you can send it to whoever you want because there's no laws, really.
You can settle money in US dollar or in rupee attached to the rupee.
Unless you turn it into
Rupee attached.
yeah, exactly.
We can, right?
Yes.
I'm sorry, that's all we have time for.
All right. Are we out of time? Okay. So
Great.
happy to talk to people
Yes,
separately.
thank
My
you very
business
much.
cards everywhere.
And you promised to send a link, right? With the slides.
Yes, I will
What are
send
the
them.
slides?
How do should I slide share them or?
We'll put it on Meetup.
Okay, we'll put it on Meetup.
Yeah.
I'll put them on SlideShare too,
Yeah,
or I'll link them
cool.
from Meetup to SlideShare.
Yes.
Please tweet me or email me or WhatsApp me or pick one of the others. I have
Yeah.
Line and WeChat and
Yeah.
everything,
Okay.
so
Right.
it's all there. So thank you, please, thank you for
everyone.
coming.
Yes.
Photo?
Please send me feedback.
Yay, photo, yeah, why not?
Yeah,
Photo.
why not?
Let's do it.
Photo.
Come on, photo. Photo.